In this video, I talk about an application to give you further insights into the working of the I-CAPM and the Fama-MacBeth approach for estimating the market price of factor risk. The application is based on the JF publication of Professor Petkova in 2006. She finds that the Fama-French factors HML and SMB are correlated with innovations and variables that drive an investor's investment opportunity set. In that sense, the Fama-French three-factor model can be viewed as an I-CAPM equilibrium model, where HML is a factor premium for duration risk and SMB is a factor premium for distress risk. The empirical analysis of Petkova 2006 relies on Merton's intertemporal CAPM. Think of the I-CAPM as a dynamic version of the static CAPM. In a static CAPM, investors have a single period investment horizon and do therefore only care about today's investment opportunity set. It's well known that the corresponding expected return of asset I is given by the following expression, which more formally is the expected risk premium of asset I. Here Rm is the market-wide return, beta Im is the regression coefficient that you obtain when regressing the excess return of asset I onto the market's excess return, and alpha coincides with the regression intercept and should be 0 if the CAPM holds. Now, in reality, investors make investment decisions on a continuous basis. Now, that implies that a risk-averse investor wants to hedge the risk that future investment opportunities deteriorate. The resulting return-risk factor relationship is known as the I-CAPM and was formally introduced by Merton in 1973. Now, Petkova's JF publication in 2006 uses the following I-CAPM characterization. Now, the terms U, like UDY, U-term, UDEF, and URF, they stand for innovations in the dividend yield, innovations in the term spread, innovations in the default spread, and innovations in the risk-free rate. The term lambda, for example, lambda U term, stands for the market price for innovations in the term spread. The respective beta coefficient, like for example beta I, term, stands for the factor exposure that asset I has with regard to the term innovation risk factor. Now finally, to implement such a model empirically, investors and risk managers have to estimate the surprise innovations. Petkova 2006 assumes that the dividend yield, the term spread, the default spread, and the risk-free rate, as well as the HML factor and the size factor, follow a Gaussian vectorized AR1 model. Therefore, the estimates of the U terms like UDY, U-term, UDEF, and URF, they coincide with the respective regression residuals. So how to interpret the HML premium of Fama in French given the Petkova finding? Well, Fama French in 1989 highlight that positive shocks to the term spread signal bad innovations to the business cycle. Now, this implies that value stocks are riskier than growth stocks in bad times. Notice that in terms of expected returns, this means that value pays out higher expected returns in times of rising term spreads, therefore in times of recessions. But that means that the HML strategy loses money during recessions, when investors' marginal utility is high. So we use the Petkova 2006 analysis as an example for understanding the Fama-MacBeth method for estimating market prices of risk. The ICAPM suggests that the innovations UDY, UTerm, UDEF, and URF are risk factors, which in addition to the market risk premium, affect the return on equity of all firms. Notice that these innovations are not portfolio returns. We therefore have to estimate the risk premium that investors require for exposure to these innovations explicitly. Now, Fama-MacBeth proposed a very popular framework. That framework consists of two steps. First, a time series regression, similar to the CAPM regression, which is determining the beta risk premium exposure that each firm I has on the risk factors. And the second step that uses the estimated betas from the time series regression and runs cross-sectional regressions, meaning for each point in time, we would regress the realized excess returns of all firms on their respective betas in order to determine the price of risk for innovations in the dividend yield, the term spread, default spread, or the risk-free rate. And note that the t-statistic will tell us whether the unconditional price of risk for these innovations is statistically different from zero, and it will also tell us the sign, whether it's a positive risk premium or a negative risk premium. Now, note the following practicalities when implementing such an approach. Now, Petkova estimates full sample betas, but she also compares her results to betas that were determined with 5-year rolling window regressions, as originally done in Fama-MacBeth 1973. Now, Petkova shows that both methods provide the same results. Now, the second practicality is that the estimate for beta I itself is the result of the first stage regression. Therefore, the regressant for step 2 is a typical example for an errors in variables problem. Schenken's correction of standard errors is a method to adjust for the otherwise overstated t-statistic. And the third practicality is with regard to the estimates of the vector autoregressive system. Now, Campbell in 1996 emphasizes that it's hard to interpret estimation results for a vector autoregressive factor model unless the factors are orthogonalized and scaled. And Petkova follows that approach, so she triangularizes the vector autoregressive system similar to the suggestion in Campbell 1996. Methodology-wise, she relies on the Gram-Schmidt orthogonalization. And also, as in Campbell 1996, all innovations are scaled to have the same variance as the innovation in the market excess return.
Got feedback? We would love to hear it. Please drop us a line. And if you liked the video, give it a thumbs up. And don't forget to subscribe to the channel.